Hello dear students of plus 2 medical and non-medical, respected teachers. So today I am going to discuss self-induction from the chapter of EM induction. So let us start with the definition of self-induction. To understand self-induction, suppose we have a coil connected to a battery and a key. Then when we close or open this key, that is at make and break, what happens? Current takes some time to grow to its maximum value at make when we close the key, and at break when we open the key, it takes some time to decay to zero value. This delay to attain maximum value or zero value at make and break is due to self-induction, because at make and break, when current grows or decays in the circuit through the coil, then self-induced EMF is produced, which opposes the cause in accordance with Lenz's law. When current grows in the circuit, it opposes the growth. When decays in the circuit, it opposes the decay of current. So this phenomenon of production of induced EMF, the phenomenon of production of induced EMF when current varies in the coil, is known as self-induction. So again, the phenomenon of production of induced EMF when current is varying through the coil, that is at make and break, is known as self-induction. Now, when current grows in a circuit through the coil, magnetic flux linked to the coil also increases. It means, and this magnetic flux is directly proportional to current through the coil. So more is the current, more is the magnetic flux, or phi is equal to Li, where L is known as coefficient of self-induction or coefficient of self-inductance. And if I is equal to 1 unit, then phi is equal to L. So from this equation we can define coefficient of self-inductance. So coefficient of self-inductance is numerically equal to magnetic flux when unit current is growing in the circuit through the coil. If we differentiate equation number 1, it will d phi by dt is equal to L di by dt, or E is equal to minus L di by dt, because by Faraday's laws of EM induction, induced EMF produced is directly proportional rate of change of magnetic flux. So if we put minus sign here, so minus d phi by dt is equal to E induced EMF. So E is equal to minus L di by dt. This is another expression for self-inductance in terms of induced EMF. This equation number 1 gives self-inductance in terms of magnetic flux. So it means if di by dt is equal to 1 unit, E is equal to L numerically. So coefficient of self-inductance is numerically equal to induced EMF produced in the coil when current is varying at the unit rate through the coil. Now units of self-inductance in AC system, unit is Henry, written by 1H, and in CJ system it is EMU, that is electromagnetic unit of inductance in CJ system, and 1 Henry is equal to 10 raised to 9 electromagnetic unit of self-inductance. So this gives the relation between SI and CJ unit of inductance. 1 Henry is equal to 10 raised to 9 EMU of inductance. From this equation we can define H also, that is 1 Henry. So self-inductance is said to be 1 Henry when current varying at 1 ampere per second produces induced EMF of 1 volt in the coil. So this is 1 Henry. Similarly, we can define 1 EMU of inductance. So these are the units of self-inductance. Now we have to find expression for self-inductance of a plain coil. So suppose we have a plain coil having n number of turns, radius r, carrying current I, then there will be magnetic field at center of the coil, direction which is given by Fleming's right hand thumb rule. So it will be directed inward, current is clockwise. So magnetic field at the center of the coil, we have already derived this expression, is given by B is equal to capital N mu naught I by 2R. N is the number of turns, I the current to the coil, R the radius of the coil. Now magnetic flux by definition, phi is given by NBA. Therefore phi is equal to N, substitute the value of B, N mu naught I by 2R into area of coil, pi R square, 1R cancels. So we get phi is equal to mu naught N square pi R upon 2 into I. Equation number 3 say, now as phi is equal to Li by definition of self-inductance. So comparing these two equations, we have L is equal to mu naught N square pi R by 2. So which is the required expression for self-inductance of a plain coil carrying current. And it shows that self-inductance of a plain coil carrying current is directly proportional to the square of the number of turns of the coil. So more is the number of turns, more is the self-inductance. It is directly proportional to radius of the coil. So more is the radius of the coil, more is the self-inductance. Then self-inductance of a solenoid. So solenoid, again a coil having large number of turns, wound on rectangular frame, maybe air core or soft iron core. Suppose small n is equal to number of turns per unit length of the solenoid. Then magnetic field well within the solenoid at its axis given by phi B is equal to N mu naught I. N the number of turns per unit length. This is the magnetic field inside the solenoid, N mu naught I. And again phi is equal to NBA. So therefore phi comes out to be capital N into N mu naught I into A. Where capital N is equal to N into L, total number of turns. So put N, capital N is equal to small n into L, N in mu naught I into A. So phi is equal to N square mu naught A L into I, or phi, also phi is equal to Li again, comparing these two. So we get L is equal to self-inductance N square mu naught A L. So this gives the expression for self-inductance of a solenoid carrying current. If we change it, the small n into capital N, so it will be capital N square upon L square. So 1 L will cancel, so it will be mu naught N capital N square upon A into upon L. So which is the required expression for self-inductance in terms of total number of turns. So it is again clear that self-inductance is directly proportional to square of the number of turns of the solenoid for a given area of cross section and length of solenoid. So self-inductance depends upon number of turns mainly. So when the number of turns is doubled, so self-inductance becomes 4 times. Now we can also calculate energy associated with the inductor having self-inductance L, because when current varies through the inductor, self-induced EMF is produced. It means which opposes the growth of current or decay of current. It means in order to maintain a sufficient amount of current in the circuit, work has to be done. That work done is stored in the inductor as its energy. So to find energy stored in the inductor, so the amount of work done, if E is the potential difference, so equal to induced EMF so produced. So by definition of potential difference or induced EMF, dW is equal to E dQ. Now E is equal to L di by dt, we have proved, or Q dQ is equal to I into dt, dt cancels. So small amount of work done in order to increase the current by d